Hello everyone, this is Team HTTPS from Sharn Ankar Kachi Engineering College. I would first like to start with the introduction of my teammates. I am Bhavya Shah, the team lead, mathematical modeling specialist in astronomy and research analyst. The next is Krishita Rawat, front-end developer and research analyst. Hetal Dabi, our presentation and documentation head. Tirth Madane, our computational analyst. Rishit Solanki, our backend developer. And finally, Khushbu Chheda, our app developer. I would first like to start with explaining the problem statement. Ancient Indian astronomers built different types of yantras across India. Some of them are Samrat Yantra, Ram Yantra, Jay Prakash Yantra, etc. These instruments are used to keep track of celestial objects and also predict astronomical events such as eclipses. Many have been built across India in places such as Delhi, Jaipur, etc. Ujjain was used as the reference time for timekeeping. The challenge of this problem is to develop a software that will generate dimensions of these instruments for any point and latitude and longitude across India. So we are basically going to build a software that will help take inputs such as yantra, latitude and longitude, and our final output will be the dimensions of different yantras. I will start with the proposed solution. It has the mathematical core of developing unique and high precision trigonometric models for core yantras such as Samrat, Ram, Jaiprakash, Digmas, etc. Location calibration. Our system will automatically calibrate the instrument's main axis, known as the gnomon axis, to perfectly match the user's input local latitude. This is more of the Samrat Yantra. We have pure trigonometric dimension and generator, the co-function that takes latitude and longitude within India and then it processes them through formulas to deterministically output all required geometric dimensions. Historical and geospatial alignment. The input longitude is utilized to implement historical time correction logic, just as I mentioned for Ujjain, relative to the Ujjain reference meridian, ensuring computational and historical authenticity. 3D model visualization. Our model, along with generating dimensions for particular yantras, also generates a dynamic interactive 3D model of the yantra. This model is annotated with the labels showing the calculated dimensions, which provides a clear visual representation. We have a modular and scalable architecture, which will be designed using object-oriented framework, where each yantra acts as a separate pluggable module. This ensures that the solution is very scalable, allowing for easy future addition of new instruments without rewriting our base engine. Our technical approach goes as follows. Our front end includes creating an app as well as a website using React.js and React Native. Using Framer Motion and I18 libraries, we are using I18 libraries to include language support. Our backend will include Fast API, Python, mainly MySQL for storing database, and as well as Firebase. For AI and computation, we are using NumPy, Pandas, SymPy, SciPy, Matplotlib, and Shapely. API and data services are as follows: Google Maps API, ISRO's Bhuvan API, and Custom Calculation API. We will be using this to locate the geographical position that the user enters. Cloud and deployment. We will be using AWS and Docker. We will also be using GitHub for our personal management. We have also used other tools such as Postman to check our APIs, Grafana, Figma, Google Docs, Canva, Jira, and MS Excel. So this here is our app flow. This is the user input that the user will give, his latitude and longitude. We will also be providing them an option to select the particular city so that they do not have to give a particular latitude and longitude. We will also be giving them an option to select the yantra for which they want to generate dimensions. Here is the astronomical calibration engine. The latitude will go into the astronomical calibration engine and it will calculate primary astronomical parameters based on latitude. such as for Samrat Yantra, we will be calculating gnomon angle using the latitude. The next user input, the longitude, goes into the longitude and time correction module as explained earlier for the Ujjain reference. And the next is the yantra type. Our selected yantra type will go into the yantra model loader, and our particular loader will load, such as Samrat, Ram, etc., and it will provide its trigonometric dimensions, etc. All these three selected astronomical calibration engines parameters, the correction module, and the selected yantra, they will go into our geometric trigonometric computation engine. This is the heart and the brain of our solution. This will generate the dimensions such as radii, wall tilt, etc. Along with this, the user will also be viewing a 3D simulation view, which he will be able to move, rotate, and on top of this, he will be seeing the dimensions visually on it. The feasibility: technical, operational, and economical. We are using mathematical and geometric models which can be automated using Python libraries such as NumPy, SymPy, and SciPy. We are using city to coordinate mapping which can be achieved using APIs so that the user does not have to enter particular latitudes and longitudes. We are also giving 3D visualization which is supported by 3.js, which allows for precise modeling and angle visualization for the user. The operational feasibility: it is very easy to use with city input fields and instant 3D output. We are also giving the support of regional language and interactive 3D view, which improves the user understanding. It can be deployed as a mobile application for wider accessibility. The economic feasibility of the idea: we can generate revenue through educational subscriptions, museum partnerships, and cultural tourism apps. The government and heritage organizations can co-fund our project for cultural preservation. B2B and B2G opportunities with educational boards, observatories, and heritage research institutes. The challenges and its solutions. The potential challenges and risk, as well as the strategies to overcome them, will be explained by me in steps coming below. Complex geometric calculations. So this is a very major part of making the solution, for which we will be using SymPy, SciPy based algorithms, and we will be validating the geometry datasets. Coordinate accuracy variations. So we are using high resolution geological APIs such as Google Maps and Bhuvan API. Lack of historical measurement data. So we can collaborate with observatories and research institutes for accurate data. There can be trust issues among users, and thus we are optimizing the models and rendering them to show 3D visualizations using 3.js. Awareness and adoption in education. We can integrate with digital learning platforms and cultural heritage programs. So these below are the supporting facts for the feasibility and challenges and solutions. Impact and benefits. There are several impacts and benefits of the solution: economical, cultural, educational, scientific, traditional, technological, tourism, and environmental. So we digitally model and simulate ancient Indian yantras. It generates accurate dimensions for any given latitude and longitude. It can be a learning tool for Indian astronomy and mathematics. It enables students and researchers to understand working principles of ancient observatories. It has a very great alignment with AICTE. It supports the Indian knowledge system vision of Bharatiya Gyan Parampara by transforming ancient observatory principles into accessible digital tools. The cultural and traditional impacts are: it supports heritage conservation. We also document India's ancient astronomical and mathematical knowledge in a very digital format. So we are also providing a teaching module for the users which let them know how these yantras work, and it provides the entire detail. The economic and touristic benefits are: it promotes interest in Jantar Mantar observatories such as Delhi, Jaipur, Ujjain, Varanasi. It encourages development of heritage-based educational apps and digital museum content. Environmental benefits are: It encourages sustainable use of historical observatories through virtual simulations. So the impact on the target audience are as follows. The first and foremost impact is on students, researchers, educators, and astronomers. It provides precise design data for experiments and comparative studies for researchers. It offers interactive visualization and virtual models for hands on learning for the students. And it also promotes curiosity and deeper understanding of these Indian innovations that took place decades ago. Cultural institutions and archaeologists. It assists heritage department in accurate restoration of the models. It creates a permanent digital archive. Government and policymakers, it supports Digital India and Incredible India initiatives. It enhances the India's image as the cradle of astronomy. These are the research and reference materials. This is our research workflow. We have done a thorough comparative analysis of the related systems. So I would now like to show you our Kaal Yantra's live demo. So here is our Kaal Yantra, ancient Indian astronomical instruments digital calculator. This is just the UI and UX, and no mathematical modeling has been done yet in this system. So we'll be providing a location input, selecting city, latitude in degrees, longitude in degrees, and selecting the yantra type. So let's say we are selecting Mumbai. So the latitude and longitude has been automatically selected for it. Let's select the yantra type as Samrat Yantra, and thus we can see that these dimensions will be automatically calculated. Let's say if we are supposed to see Ram Yantra, these things will change here, Digams Yantra, and so on. We can also download the blueprint of these dimensions. I would like to now show you the 3D visualization process. So this will be our 3D visualization preview. This actually will be user interactive, and they will be able to see the dimensions here. And this is our add-on, which is learning more about Samrat Yantra. So when we click here, this is the detailed information about Samrat Yantra, and thus we are also a teaching website. Thank you.